Hey, this is Mr. Ng going over your Math 5 quiz number 1, volume 1, module 1, topic 1 to topic 2, taken September 6, 2019. This is version H. Show all your work in the space provided and box your answers. Question number: which equation is equivalent to 5x minus 2 times 7x plus 1 equals 14x? So here they're not asking you to solve for x. All they're doing here is just asking you to find which one is equivalent. Something that you can do is, in order to solve, so how do I know it's solving? You see an equal sign. What does that entail us if it's solving? Let's see if we can get that. That's kind of... if you are solving, then in PEMDAS, you're going in this direction. But notice how they have the 14x on this side, and you kind of just need to simplify the next step. So the reason why you would not subtract is a couple of reasons why, is that they're not like terms, meaning this one has an x and this one does not have an x, so you cannot say 3x. Another way you know not to do 5x minus 2, even though it's the first thing you see from going from left to right, is that that would be subtraction. Addition. So on one side, essentially what you're doing on that side there, you are simplifying. So we're just simplifying here. So just pretend the 14x is not there. Like what are the math steps you can do next? So this negative 2 here, you're going to distribute. And if I distribute there, I get 5x minus 14x, so negative 2 times 7x, and negative 2 times 1 is negative 2. And then there on this left side, all I'm doing is just simplifying. So I'm going to do adding and subtracting. So that would be these two. So 5x minus 14x gives me negative 9x. So there we're combining like terms. And the only one that matches that is choice A. So we've been working on finding equivalent expressions, and all you have to do there is just combine like terms. Get some better lighting. If that helped or not. Okay, next question. Terrence asks his employees to determine the number of tiles added to design 2 to create design 3. So going from here to here. Each employee describes a unique method to determine the number of additional tiles needed to create design 3. So again, they're going from here to there. So draw an arrow. Going from there to there. Represent each of the employees' explanations with an algebraic expression that describes how many new tiles must be added to an n by n square to build the next design. So again, n means the edge tiles or the design number. That's what we did in class. So this problem's directly from class. I must add 5 tiles to 2 of the sides and 3 tiles to the other 2 sides. The number of additional tiles added to design 2 square floor design is 2 times parentheses 3 plus 2 plus 2 times 3. So we talked about in class how from here to here, your design number is n. In this case, n is equal to 3. So if I put an n here and n here, I'm going to get something that looks like this. 2 times n plus 2 plus 2n. And that is our expression. 2 times n plus 2 plus 2n. And that's the answer. So in class we did that same exact problem. You just have to remember the design number is equal to n. N is in this case 3 because you're going from design 2 to design 3. So I'm placing every 3 with an n. And that would help us figure out the next design number or outer edge. Question numbers 3 to 8. All right, for the next set of questions, Questions 3 to 8. Identify and circle each as linear for L, Q for quadratic, E for exponential, or N for neither. So for a table of values, the first thing you're going to do is just figure out, are you adding or multiplying? In this case, I see that I can add 4, I can add 6, and I add 8. So if this was the same number, that would be the first common difference. That would be linear, but this is not the same number, so it's not linear. Remember, this is not multiplying, so it can't be exponential. So let's figure out the next set. So then from here to here, I am adding 2, and then I'm adding 2. So this would be a second common difference, which would be quadratic is your correct answer. Question number 4. I have a smooth curve here, so that is not linear. Then I have Q. That would be quadratic. Quadratic would be a U. And then E is exponential. So this is exponential because it's a smooth curve, and what it does is it rises rapidly or declines rapidly. So this would be a growth. And then remember, quadratic is like more like a U with a smiley face or a smiley face down. Question number 5, that's what we just talked about. Smiley face down, that would be quadratic. And question number 6. I want to focus on this part right here. So the answer for this one is exponential. And it fits that equation you had on your foldable. A is your initial value, or you can call this your G1 value. And then that's times the R value. And then N minus 1. So the R value is your ratio multiplying by 3. So look at here. This is your base. And normally for linears and quadratics, that's a variable, like variable x, and then you would have a number normally. But in this case, it's a variable up here, so that would be exponential. Question number 7, you'll notice that these are both to the first power, so the answer is linear, because if you subtract 5x, you're going to get y equals negative 5x plus 8. And this is in the form of mx plus b. Remember, the 1 is right there for the first power. Question number 8, you have a table here, and if that's confusing, you just change your table this direction. So I'm just going to write the x values, negative 2, negative 1, 0, 1, and then 2, negative 1, 1, 3, 5, and then 7. And then there I'm just figuring out what's happening here. So I realize from negative 1 to positive 1, that is a plus 2, plus 2, plus 2, and then plus 2. So you have a first common difference there. That would be linear. So let me go ahead and count the points for the page. 1 point for name, circling. So that's 2, 4, 6, 7, 8, 9, 10, 11, 12. 12 points for this side. All right, for the back side, it says draw design 7. I meant to give you guys graph paper, and then, yeah, it's just kind of difficult to see. So something you should see for design number 1 is the design number kind of tells you 1 by 1. Right? Design 2 is 2 by 2. Design 3 is going to be 3 by 3. So a design number 7 is going to be 7 boxes. 7 boxes. Let's see if I can get it just based on, kind of hard to see, but there's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Just do your best. So all we're going to do is just literally count. And then you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I don't know, I need to put one there. I'll try to make the graph become again better. 1, 2, 3, 4, 5, 6, 7. And then you add another box down there. Okay? So literally all I'm going to do is going to count that you have design 7. I'm going to count that you just have 7 boxes this direction and then 7 boxes that direction. Told you guys cross that off. That was a typo. How many squares are in the design? So if you do a 7 by 7, 7 by 7 plus 2, that gives us 49 plus 2, which is a total of 51. 51 is your answer. 9C, complete the table. So design 1, we have, if you think about it, although you can count on 1, 2, 3 as your answer, you get 1 by 1, 1 times 1, and then plus those 2 pieces. See if we can color code that. So this purple is kind of like this part here, right? Let's go one more. And then the red part, this red part, the plus 2 is on all of them. Plus 2, plus 2, plus 2, doesn't matter what design you do, plus 2. So this will be a 2 by 2 plus 2, so that would be 4 plus 2 is 6. So this is our answers. Total number of squares. And then this would be a 3 by 3 plus 2, so 3 times 3 is 9, 9 plus 2 is 11. And then a 4 by 4, which you don't even have a picture for, you can just follow the pattern. That would be 16 plus 2 is 18. And then let's just say you did 7, so it was a 7 times 7 plus 2, so 49 plus 2 is 51. And then let's just say you do, they always call that design n, so that would be n times n plus 2 would be, n times n is n squared plus 2. That'll come up later on, so, but I just wanted to stay on the table there. So again, doesn't matter what design number I pick, it was just kind of that n times itself, and then you add 2 for those 2 red squares. So is this linear, quadratic, or exponential? A couple of things you could do. Let's just say you didn't recognize that it's n times n. You have a table of values. You have 1, 3, 2, 6, 3, 11, 4, 18. Remember, pay attention that these are going by ones. And then over here, I can just say we're going plus 3, plus 5, plus 7. So that's the first common difference. It's not the same, so it's not really a first common difference. So there you would just say plus 2, plus 2. So you have a second common difference, and therefore our answer is quadratic. Quadratic, because there is a second common difference. Okay, write an algebraic expression to represent the total number of squares in design n. Okay, so the answer is already n squared plus 2. Or x squared plus 2. How did we find that using your foldable? So we would say the a value is equal to your CD divided by 2. And then our CD here was 2, so 2 divided by 2 is 1. So the a value goes ax squared plus bx plus c. This is the standard form of quadratics. And then how do I use that is I put in the 1 here for the a value. The b value we need to get, and the c value, again, is if you go up on our chart here, it's the y-intercept. So if you go move up, Well, what number would be here? If you follow this pattern, the first common difference would have to be a +1. So some number added to 1 will give you 3, or you can subtract. 3 minus 1 is 2. 2 plus 1 equals 3, and then you would still have your second common difference of a +2. So 0, 2, let's use a highlighter if I have any. 0, 2 here, that becomes your C value in your standard form. So it would be 2. And then you just need to solve for the B value. The B value, you pick any of these order pairs, 1, 3, 2, 6. I'm going to pick 1, 3 because I think that's the easiest number I see there. And all your X values are going to be 1, and your Y value make 3. So I'm going to put a 3 there. So 3 equals 1 times, and then all of our X values are going to be 1. And what that has done is now you've eliminated the X's and Y's by substitution, and you can just solve. So 1 squared is 1. 1 times 1 is 1. B times 1 is just B plus 2. So you have 3 equals B, and then 1 plus 2 is 3. You're just combining like terms there. If I subtract 3 from both sides, you're going to get a B value of 0. Which means when I put it back in that formula, y equals, our A value is 1. From over here, I don't need to write 1, so I'm just going to have x squared, or 1x squared, plus, let's put the numbers in and then clean it up. So 1 times x squared plus 0x, because our B value is 0, and our C value is 2. And then if you write this without your 1s and 0s, I have x squared, and I don't have to write that, right? 0 times something is 0, so we don't write 0, and you just put the plus 2. So either of these are called algebraic expressions. Algebraic expressions you think has variables in it, either x's or n's. Use your algebraic expression to determine the total number of squares in design 52. Well, if I have 52, that means whatever I use, let's use this one, my x value is equal to 52. So I have y equals 52 squared plus 2. Remember, 52 squared is 52 times 52 and then add 2. So we're going to have a huge number. Pull out my calculator here. I'm going to go 52 squared plus 2. And you will get y equals 2,706. The total number of squares in design 52 will be 2,706 squares. Question number 10. Determine whether the two expressions are equivalent and explain your answer. So they want to know, is this equal to that? And I usually put a question mark there. Remember, the number one temptation here is probably to subtract 43 minus 5, and that would be wrong. The reason why it's wrong is we just did that problem. That first question from the front page, it's PEMDAS. You're essentially simplifying, so you have to do parentheses and exponents first, then multiplication and division. Very, very last is addition and subtraction. So I'm going to guess, if you missed the problem, they probably did 43 minus 5, just because they see it as the first thing. But there's some rules and orders to that. So inside the parentheses, can't combine anything, so I'm just going to multiply the negative 5. 43 times negative 5x. Negative 5 times negative 2 is plus 50. And we said we're not sure if that is equal to this over here. Remember, you cannot combine like terms there because this one doesn't have an x. So then I'm just going to combine like terms here. 43 and a positive 50 gives me 93. 93 minus 5x. And then are these exactly the same? The answer is no, they are not equal. Okay. So determine, no, they are not equivalent. Let me just get the screen over or zoom out. you could put because, so my explain word is because after distributing and simplifying, so you can explain the things that you're doing after distributing and simplifying, the expressions are not the same. So I'll probably get 3 points for doing this correctly, and then 1 point for having an explanation. Question number 11. A local pet shelter is able to see that many of their pets adopted. The table lists the number of pets that have been adopted over several weeks. So here's the good thing over here on the X side. All of these are counting by ones. That's something you need, plus ones. Very important. Make sure it's not skipping any. And then the next part is figuring out the common difference on the y values. Are we adding or adding, or are we multiplying? So here I have plus 3, plus 5, plus 7, and then 32 minus 23 is plus 9. So I know it's not linear, then I know it's most likely going to be quadratic. Let's see, plus 2, and then plus 2. So it is quadratic. And then we're going to do the same thing we did in question number 9. We're going to do this part again. We're going to figure out basically our A's, C, and our B value. So let's go ahead and do that. So remember, the A value is equal to the CD divided by 2. A is equal to a common difference right here in red is 2 divided by 2, which is 1. A is equal to 1. And then a C value is just going back up. So I have 0 here, and then this would have to be plus 1, because that gives me the second common difference of adding 2. So number plus 1, that would be 7. 0 and time, and then 7. So C is equal to 7. Let's write that. C equal to 7. Let's highlight what we got so we don't forget. Or I'll do purple. I got C, I got A, so let's figure out our B value. So y equals ax squared plus bx plus c. The A value is 1. The C value is 7. We're trying to figure out this B value, and then the X and the Y is an order pair. So let's choose 1, 8. My Y value is 8, and every X value is 1. So then I have 1 squared is 1 times 1 is 1. 1 times 1 is 1. So I have 1 plus B plus 7. And then if you combine like terms and subtract, or you subtract 1 and then subtract 7, you'll get B equal to be 0. So those are all my pieces. So if I put that into here, y equals an A value of 1, a B value of 0, and a C value of 7. Then clean that up, I'll get y equals x squared plus 7. So, for example, if you put in 5, 5 squared is 25, and 25 plus 7 gives me 32, and that works. You pick in 4. 4 squared is 16, 16 plus 7 is 23. So there is my algebraic expression or equation. Then identify whether the pattern is linear, exponential, or quadratic. It is quadratic because of the second common difference. Actually, I want you guys to spell it out. Let's count out the points. So I got 2, 3, 5, 7, 9, 11, 15. 15 plus 4 is 19. And then if I take those two values, 12 plus 19 gives me 31. Ooh, I forgot to put the box there that has subtraction of points. So yours will be out of 31 points. I hope that was helpful for you.
Math.
Say it again.
Our math.